see here that I have this first part, which is y minus 2x, okay, less than or equals to 1. Now, from the introductory part of the lesson, I said the first thing you do is to rewrite this inequality as a linear equation and then put in x for 0, y for 0, so that you can get the values of the y and x intercepts. Let me just be doing it and explain it so that you get what I'm saying. So I will rewrite this as y minus 2x equals to 1. The next is that I will say when y is equals to 0. So when I put y equals to 0 here now, you realize that I will have minus, this will become 0. I will have minus 2x equals to 1. And if you divide both sides by minus 2, you have x equals to minus 1 over 2. This is the x-intercept. And then when you go down again, you say when x is equals to 0, that is this being 0, what you are going to have here now is y minus 2 in bracket 0 equals to 1. So this will go. Now realize that y is equals to 1, and this is the y-intercept. Now, another thing we try to do is when we now put up our graph, we will also like to know the area that satisfies this inequality. We like to know the area that satisfies it. And how we normally test that is we go to the origin and know what is going on at the origin, whether we are going to obtain a true statement or a wrong statement. So if we come to this origin, we bring, the origin is the point where x is 0 and y is also 0. So if we come to the origin, we say at the origin, if we come here, put x 0 and y 0 here, okay, you realize that you have 0 minus 2 into 0, okay, less than or equals to 1. So obviously you have 0 less than or equals to 1. Is 0 less than 1? Yes. So that's a true statement. It then means in showing the area that satisfies this, the origin is going to be inclusive. You are going to see me when I will be demonstrating that. Let me check out on this as well. So I will come back here and say y plus x is greater than 4. So I will rewrite it again as what? A linear equation, that y plus x is equals to 4. Then when y is equals to 0, you can see here that x will be equals to 4. And when x is equals to 0, you can also see that y will also be equals to 4 here. Okay. Then I will also check what is going on at the origin, the area that will satisfy the inequality, whether the origin will be part of it. The origin is where x and y is 0. So it then means if I come here, I will say when both of them, x comma y, equals to 0, it then means we have 0 plus 0 greater than 4. Now, is 0 greater than 4? No, 0 is not greater than 4. Rather, 4 is greater than 0. So this is not a true statement. It then means in this case, inequality, 0 is not going to be part of the area that satisfies the inequality. Whereas in this case, the origin will be part of the area that satisfies it. This third one doesn't need anything. We have x less than or equals to 3. We don't need to solve anything there. We'll just go there and show it. So let's put up the graph and see how we are going to show these 3 things on the Cartesian plane. So now from this particular one, the x-intercept is minus a half. So if somewhere here is minus 1, minus a half will be somewhere here, minus 1 over 2, half of it. And y is 1. So let somewhere here be y. 1. And another thing is, which kind of line am I going to draw here? I say for less than or equal to, greater than or equal to, we use thick line. And for less than or greater than, we use dotted line. Okay, so here I'm going to use thick line to demarcate the area that satisfies this inequality and the area that does not. I will use thick line to demarcate it. Okay, now remember we said that this is true, and because it is true, that means the origin is part of the solution that satisfies the inequality. So, and in my own concept, I shade the area that satisfies the inequality. Did you hear what I said? Because certain literature will say the unshaded region. My own, I am using the shaded region. That is the area that satisfies the inequality. I shade it. I shade it. Some literature will say the area that satisfies the inequality is unshaded. So they are still conveying the same thing. You should understand that. Okay, they are still conveying the same thing, only that they are using different ways of expressing it. Okay, so please, I am shading this way. I am shading this way as the area that satisfies the inequality. As the area that satisfies the inequality. Okay, now having done that, what about the other one? I will position 4. I will position 4. I will position 4. The x-intercept is 4. Let's somewhere here before. Okay, and the y-intercept is 4. Let's somewhere here be 4. So, and you see that because of the nature of this inequality, we are using dotted lines. We are using, let me shift this thing a little bit. Somewhere here, 4. Okay, 4. Dotted lines, dotted lines, dotted lines. There is a difference between that and this. Okay, dotted lines. Okay, now what area satisfy the inequality? Remember, we are shading away. We are shading away because the origin has been seen to be not to be outside, away from the area that satisfies the inequality. So we are shading this way. I'm using different colors so that you can be able to picture where these 3 colors appear. Where these 3 colors appear will be the area you can see is connecting already. And then finally, we are showing that x is less than or equal to 3. If somewhere here is 3, is 3. Okay, x less than or equal to 3 means this way. So, and we are using thick line because of that. You are seeing there. We are using thick line. Sorry, let me shift this thing a little bit. 3. Okay. Okay. So you can see that x, look at it this thing, x less than or equals to 3 means this way. This is the area that satisfies that x less than or equals to 3. So I can mark this area. Okay, this marker is not too bright. I'm sure you saw that. So this is the area where x is less than or equals to 3. Now my concern is here. Did you realize that within this triangle, the 3 shadings appeared here? A, B, C. Look at the triangle here. This triangle. This triangle. Did you realize that inside this triangle, the 3 shadings appeared there? So this region now satisfies these 3 inequalities. Do you get that? This region, this particular region, here, this area A, B, C satisfy these 3 inequalities. So this is how to show graphically the area that satisfies given set of inequalities. I'm sure this explanation is very, very good enough to explain to you how you can go. I'm going to take one more example, another set of examples that can also, you know, fortify your foundation in following what we are saying here. Okay, please like this video and share it to your friends out there. Click on the subscription button and promote us in what we are doing. Okay, and what again? Click also on the notification button because we still have a lot of work to do. And if God touches your heart to support us in what we are doing, please do so. Our email is down there. Thank you so much for being part of the class. God bless you.